This is AP Calculus Self-Check 7.6 solutions. So these were, again, just made from the pieces of a previous test, so they don't add up to 9. This one is actually going to add up to 8. So for part A, write an expression for the acceleration of the particle. And again, we are using the calculator for this one. So acceleration, AT, is going to be the derivative of what? Well, I already told us. Velocity.
Because you wrote it down.
I need to slow down. And by the way, for this problem, there's the parenthesis right there for natural log of t.
You told us that before and I just wasn't listening.
I should have said it again though.
Sorry,
So I need to find the derivative, and this one I can't use the calculator really to find it because I just need the general expression. So the way that I do this is using product rule. So this is t times natural log, that's why I'm using product rule. And product rule again is what? What's the rule?
1d2 minus 2d1.
No, plus 2d1.
Plus 2d1, exactly.
Oh, so we actually...
You actually need to find it, yep. So 1d2, so 1 is t, so t, derivative of 2 is 1 over t. And then 2d1, 2 is, so I'm going to add here, 2 is natural log of t. And d1 is just 1, so times 1, I can write that here, I guess. And that's going to be, all of this, I still have to subtract t, derivative of t is just 1.
Couldn't you just plug that into your calculator and be like, the derivative of y1?
They wouldn't give it.
So the calculator can only do a definite integral. It can only have it with bounds, and we don't have any bounds. This is just the general antiderivative, so you have to be able to know how to do this by hand. So this simplifies a t divided by t is just 1, and then a 1.
Do we have to simplify it? I thought you said on the
Don't simplify it, no.
Oh, okay.
Once you get this, you're done. Yeah, you get your point here. But I'm going to simplify it because in my class, you do need to simplify. Otherwise, I'm not giving you a point.
What? I'm still putting a point.
It's a waste of time.
I know. I know it's a weird thing for the AP test. For in my class, always simplify. I need to practice. So t divided by t is going to be 1. 1 minus 1 is going to be 0, so those cancel out. And 1 times this, I'm just left with natural log of t. Natural log of absolute value of t.
So all I did was write out a of t equals v prime of t, so that gets me no points.
Right.
Because I just thought it was like the expression.
Nope.
If you don't have the absolute value signs...
You need the absolute value signs.
And it's always with ln, right? Wait, is it always with an ln?
Always with natural log, just always put absolute value sign.
I just always forget.
All right, so that was 1 point. Let's go to part B. For what values of t is the particle moving right? Moving right, what's the definition of moving right?
It's going above the x-axis.
Yeah, and both of you have it correct. So Rosalie said v is greater than 0, which is the symbolic notation, which I'm going to write down. And Sophia has the graphical representation just above the x-axis. Yeah, everyone, good job. All right, so I need to find the values where it's moving right. So the way that I do that is I need to use my calculator. Let's pull that up. So on my calculator, I need to go y equals, and I need to enter my t times the natural log of t, n parentheses here, minus t. And my window is going to be set from 0 to 4, 0, enter, 4, enter.
I hit it to 6, is that okay?
That's fine, as long as you make sure your integral is correct, or your interval is correct. I hit zoom 0 to make sure my y-axis is scaled accordingly to my bounds here. And you should have this graph.
It looks like it.
So we need to figure out, it's moving to the right, obviously, in this interval over here, but we need to figure out what this point is. So how do I do that?
0.
Yeah, I need to find the 0. So second trace, and I need to find the 0, so I hit 2. So my left boundary, I'm going to move over here to the right a little bit. That's a good left boundary. Good right boundary.
Wait, can you go?
Enter.
Enter in.
Enter. If you want to try it, but this one is a little bit exact. You have to do 2.7182818. This is actually E, by the way. So that is the interval. So it's going to start here, and it's going to go.
Got that though.
Oh, perfect. By entering in. How'd you get this without doing?
0 and
Oh yeah, yeah. So you didn't do the left arrows. You actually entered like 0 and 4.
yeah.
Yeah, that's perfect. So I'm going to show that method as well. So second trace 2. So Carly noticed that there is only 1 0, so she probably just hit 1 for the lower boundary, 4 for the upper boundary, and the guess, I don't know, about 3 roughly, and you'll get the same answer of E.
Yeah.
Faster way of doing it. Good job. That saves time right there.
Thank you. I just thought that's what we were supposed to do.
Yeah,
So
Can we do that one day?
We did, yeah. I taught us particle.
I knew this.
Well, I'm saying that because in other classes for AP Calculus, there's a lot of people that are just struggling to grasp the basics of the calculator. Everyone in here is almost a master at the calculator now, where you learn these tricks.
You taught us well, sir.
That's what you think.
So particle is moving right for this interval. For 2.718 to t to what?
4.
To 4, exactly.
Wait, I put 6.
And we don't get your second point if you don't explain your answer. So to explain our answer, the reason is because, what is our reasoning?
Those values are above the x-axis.
Yeah, because velocity is 0 for that interval.
Do we have to say velocity is 0?
Nope, your explanation is perfect. You'll get your point.
Does it matter if we did less than or equal to, or like just less than? Sorry.
They don't check.
Okay.
They just want a general interval. And you can make a note here if you want that this number is E. If you go on your calculator actually and check this, if you do get out of here and you do second divide and you hit enter, 2.718, this is the value of E.
Whoa.
Just kind of a
So no, what if I put
random tidbit.
t is greater than 0 when t is greater than 2.7?
You have to have that end interval. You have to go to 4, otherwise you don't get your point.
For that?
Nope.
Or do I just get 1?
You don't
I
get.
calculated it right.
You have to have that end interval because otherwise you're not using this. Sorry, you don't get your point. But that's okay. This is just a self-check. On the test, now you know to do it. So you get 1 point if you got the interval correct, and 1 point if you explain something about velocity being greater than 0, something about being above the x-axis for velocity. Wait, Sophia, did you mention velocity in your answer? Above the x-axis in the graph of velocity?
No.
I'll be nice this time and say you can have that point, but in the future you have to have the word velocity in there. This explanation has velocity in it, so it's a little bit easier to memorize. Memorize this.
So because the velocity is greater than 0 for that interval. Okay.
Yes. All right, on to part C. Part C is a little bit long, so whenever we're doing farthest to the left, farthest to the right, then we have to make a giant table. So let's go ahead and do that. Time
Me too. Except I really
Start.
It looks so neat.
plus change
Getting it.
Yeah.
But still.
is going to equal our end.
Yeah, it takes so long.
Do other kids do tables?
Yes.
Do other kids do tables? Well, you know, like, not all the other kids do tax.
Yeah, it is.
So I always think, like, are they, like, looking at her like, huh?
Yeah, well, they can probably do it in their heads with the calculator, but they'll make an error. This system, over and over again, you'll always get the right answer. What are our values for t that we should plug in, girls?
0, 2.718, and 4.
Oh, man.
We are
You're on it today. Good job, yeah. What's our start value?
6.
Yeah, and it came from right there. Perfect. 666, the devil.
I can't do this problem.
So,
6 because, like, I kind of understood why it was 6, but, like, because the velocity at 0 is 6. Or time. Oh, okay.
At time equals
Well,
0.
At time equals 0 and 6. Okay.
yeah, so all these integrals are going to be between 0 and whatever time we're given. So 0 to 4 for this one. Vt, dt. We are writing this, right?
Yes.
We're writing all of this, even though it's tedious and you do the same thing over and over again. You are writing this?
Still right.
Yeah.
Okay, good.
Well, at first I was scared that I was supposed to put 6 to 0 because the start, I just totally brain farted.
Oh.
But
Yeah, that's-
it's always 0.
Always 0, yeah.
Brain fart.
Okay, so how do we solve these? With a calculator. So I'm going to do the graphical representation for one. I'll do the numerical representation for the other. So how do I find, well, 0 to 0, we know that's just 6. That's easy. But 6 to this, so 0 to 2.718. So I'm going to go to my, I don't have to go to graph, but on my graph, I'm going to do second trace, and I'm going to calculate the integral for 7. And my lower limit is 0 on this, and then 2.718. You can enter 2.718. I'm going to be fancy. I'm going to do second E, because I knew the upper limit was E. Oh, it's exact. Mr. Snell's exact. And you get negative 1.84, but we need to add that to 6, so don't just put that. So the quick way to add it, here's the way to add it quickly. You just get out of here. Second escape, do second answer. That second answer is the thing that I just got from the previous screen, and then I'm going to add that to 6.
Can you just put at plus 6 and it would be answer plus 6?
Oh yeah, you could just hit plus 6. You don't have to hit second answer.
Mr.
You're right.
Do we have to use the graph on that? Because what I did is I just did like math 9 and then like took the integral.
No, yeah, that's what I'm going to do for this second step. I want to show it both ways. That's completely fine.
That's what I did too.
All right, and then I'm going to do it this way that you're just talking about now, from 0 to 4 for my integral. So again, y1 is still correct there. So I'm going to do math 9, and that's going to be the integral. 8 would have been the derivative. So math 9, and we're taking function 1, y1, and that's going to be with respect to x from 0 to 4, and parenthesis. And I'm just going to go ahead and add 6 all at the same time here. I don't have to worry about that as a second step. And it will take a bit of time. And 5.090.
Yay!
5.090. All right, so obviously farthest to the left, that's going to be the smallest one. So this is the position, but are we done? Is that the answer?
No.
No, because we're finding the time. So
So you're finding the lowest
farthest left at t equals, at time equals, I'm going to be E because I'm going to be cool. All right, so how do we score this thing? So you get 1 point if you have your initial conditions. So initial conditions right here, that's +1.
Wait, do we have to write E?
No.
Okay.
At 2.718 is fine. You'll get your point.
Yeah.
All of that work, if you do it correctly, that is +1. And if you say it's farthest left at time equals 2.718 or time equals E, give yourself another +1. So we're at 1, 2, 3, 4, 5, 6, and there's going to be 2 more points for part D. Let's go ahead and do that. For part D, find the total distance traveled. Total distance traveled is what?
Absolute value.
Yeah, there it is. Absolute value integral. So from 0 to 4, because those are our bounds here, 0 to 4 of velocity of t. Right now, what do I have? Without the absolute values, what do we have?
We have
What is this without absolute values?
displacement.
Ah, there it is. Total displacement. Yeah.
Except when you have the absolute value.
We're doing the dance if you can't see in the video. Yeah, so how do I do this on the calculator?
Wait, I got it. Like position change, like you're like moving your hips, like
Position change.
So on the calculator, did you guys use the graph or did you use non-graph?
I use graph.
Graph? Okay, so you can do either way. I'm going to do the graph because it seems like that's what most people do. You can do it with this f integral, and instead of doing y1, you can do abs, absolute value. So what I'm going to do instead is I'm going to make a new graph. So I think this is the way that you did it. You turned off that graph and you said, I'm going to do the absolute value abs of y1.
Mr. Snell, I did it super hard. Is that
You calculated 2 intervals and then made the other one
yeah, and
negative?
I added them together because I couldn't remember how to like exactly do everything, so I was like, I'm just gonna do
That's fine. So if you do it this way, it already makes both of them positive.
Isn't that cool?
And then you can do second calc 7 from 0 to 4. And it does take a while. And I already know the answer because we did this ahead of time, and it is 2.784.
785. What if I got that?
785, I think, if you rounded correctly.
If I rounded, yeah.
2.785, yeah. That's, let's go ahead and change that to a 5 because we're rounding correctly. 2.785. And how do we score this thing? So obviously the answer is 1 point. And if you put absolute value, if you have this integral set up correctly, that is another 1 point. So total out of 8. Out of 8. Call out scores. What do we get?
I got 7.
Oh my gosh, 7.
I got 6.
Very nice. 6.
I got 4.
That's still really good. You are passing.
I got 7.
Wow, very nice.
I got 5.
Very good. Enjoy.
I don't want to say.
I want to know. I can talk to you after class. Okay, good job, girls. We are out of here. We still have 4 more minutes left of class, so I'm going to end the video now.